Okay, this section of the chapter is the last section. And this deals with kind of like a practical application of how to use this stuff. First of all, let's make sure we understand what a rate is. A rate is a comparison of two measurements. Usually the second one is time, like miles per hour, and so on, meters per second, etc. So generally it's going to be over some kind of time thing. So when we derive stuff, we're going to be deriving like dx of dt or dy of dt. You get it in rate form, varying with time. If you open up your books at page 154, we're going to do some odd number problems to kind of give you an idea of how to turn this into that. The first one is y equals the square root of x. And what we're given here, first of all, they want us to find dy dt. We also want to know what that is at x equals 4. And we're given that dx dt is 3. So we're going to find the derivative of each side here. So this becomes dy dt, rather convenient, equals, now, this can be rewritten as x to the 1/2 power. So the 1/2 comes down front, and then you subtract 1 or 2 halves from 1/2, we get negative 1/2. So we can rewrite this, and this is dx dt. And we can rewrite this in a more conventional form, like negative exponents in the expression. This will be 1 over the 2's in the denominator already, and this becomes square root of x in here. dx dt. And as you can see, everything's pretty much spelled out. So we're trying to find dy dt. So I'll rewrite this. dy dt equals 1 over 2 square root of x dx dt. And start plugging in stuff. So we're trying to find dy dt. So that's the unknown. Everything else should be known. 1 over 2, that parenthesis times the square root of x, and what x is 4. The square root of 4, which of course is 2. And then dx dt is given to us as 3. So we do the mathematics. Square root of 4 is 2, 2 times 2 is 4, 1/4. 1/4 times 3 is 3/4. And that would be our value of dy dt. Okay? Now that's actually part A. The whole thing's all part A. There's a part B where they want us to find dx dt given other values. So we're going to have the same expression that we got there. So I'm going to rewrite this right here. dy dt equals 1 over 2 square root of x dx dt. Okay, and now I'm going to plug in values here. Now let's see what we're given here. We're trying to find dx dt. We know that x equals 25, and dy dt equals 2. So we'll just plug in and use our algebraic skills. So dy dt is 2, 1 over 2, and put times the square root of 25, which we know is 5, times dx dt, which is what we're solving for. Well, square root of 25 is 5, 2 times 5 is 10. So we're going to multiply both sides by 10 over 1 to remove it. from the dx dt. So these cancel out. We're left with 2 times 10. So that means then that dx dt equals 20. Not too bad. Let's take a look at number 3. We're given here that xy equals 4. And they want us to find dy dt when x equals 8. And given that dx dt is 10. Now, in this particular situation, since they're asking specifically for dy dt, I'm just going to go ahead and change this, rewrite this, if you will, so that x is over here. So this becomes y equals 4 over x. I'm doing that because if I want dy dt, then that's going to be by itself automatically. I don't have to do any more work. I am going to rewrite this as x to the -1, though. Will equal 4x to the -1. All right, so now I do the derivation thing here. Dy dt equals, and now 4 is multiplying the x, so I'll bring that to the side. -1 comes down, and then subtract 1 from -1, you get -2. So when the dust clears, we get -4 x to the -2, which is -4 over x squared. And this is going to be, this would be dx dt here, and this is dx dt here. And so now we're ready to plug in stuff. Since x is 8, this becomes then -4 over 8 squared times, and then dx dt we said is 10. Okay, so this gives us then -4 times 10, which is -40, over 64. Divide 8 into this fraction that now needs to be simplified, and you get -5/8, or if you divide that out with the calculator, -0.625. Okay? All right, now that's a specific type of problem. We've laid out everything for you. I'll do one more. Oh, and then that's when they want us to find dy dt. It's done pretty much the same way we did the previous problem, so I'm not going to do that. I'll do one more, number 5a. We're given here that y equals x squared plus 1. And they want us to find dy dt when, trying to read my notes here, when dx dt is 2 centimeters per second, and x equals -1. Okay? So, in fact, that's the thing about 6 and 8 that you're going to do. You're all going to have dx dt being this 2 centimeters per second. So, again, derive this dy dt equals, this becomes 2x plus 1, because it's adding now, it's going to be the constant rule, which means it's going to drop out. So this is dx dt. Okay, and for this we know that this is 2 times x, which is -1, And remember, this is centimeters per second. You really need to keep that in mind because this is going to be rated well. It should also be expressed in centimeters per second. We didn't have labels for this one, we do for this. So that's the difference between the two sets of problems. And then dxdt is 2 2x 2 times the negative. Oh, this 2 is centimeters per second. The dxdt is centimeters per second. Now then, we get negative 4 centimeters per second, which means it's going the opposite direction. It's not negative, but you can in velocity physics in relation to what the previous substance is going forward or backward, left or right, up, down, whatever. Okay, so this is what you're doing for this. It's pretty simple stuff. Your practice problems. This is going to be page 154, problems 2 through 18. Okay? Good luck.